Here we have a SAT math problem. Okay, let's go to the question. F of x equals to x negative 4 the whole square negative 1. G of x equals to negative 1/4 times x negative 4 the whole square positive 4. Two functions f and g are given above. For which of the following values of x does f of x negative g of x equal to 0? Okay, let me take this equation. F of x negative g of x equal to 0. Okay, now what we have to do is we have to solve for x in this equation. Okay, let me add g of x to both sides of this equation. Okay, let me do it. When I do so, here on the left side is negative g of x, positive g of x will cancel out. I'm getting f of x on the left side. On the right side, I'm getting g of x. Okay, when f of x negative g of x equals to 0, we get f of x equals to g of x. That is, the two functions are equated. Okay, whenever the two functions f of x and g of x are equated, actually this is a way of solving the given system of equations. That is, when I get solution for this system, that is the value of x and the value of y represent the point of intersection of the two graphs given by f of x and g of x. Okay, so here to get the point of intersection for the given system, what we can do is we can use Desmos. Since it's a digital SAT, we can sketch the graphs of the two functions using Desmos graphing calculator, and there we have to get the x-coordinate at the point of intersection. So that's the value of x for which f of x negative g of x equals to 0. Okay, now let's go to Desmos and sketch the graphs of these two functions. Okay, here we have a Desmos graphing calculator. Now we have to sketch the graphs of the two functions f of x and g of x. Okay, when I give these functions as input over here, I have to replace this f of x and g of x by y. Because whenever a function is defined by f of x or g of x, it represents a y coordinate in the xy plane. Okay, now let me give the first function as input and also let me replace f of x by y. Then we get y equals to x negative 4 the whole square negative 1. Okay, now I got the graph of the first function. Now let me give the second function g of x as input. Let me replace the g of x by y. Then we get y equals to negative 1/4 times, let me do it, x negative 4 the whole square positive 4. Okay, here I got the graphs of both the functions f of x and g of x, and the graphs of the two functions intersect at 2 points. One is over here and other one is over here. Our aim is to get the x-coordinate at the points of intersection. Okay, here the first point of intersection is 2, 3. At this point the x-coordinate is 2, and this is a second point of intersection, that is 6, 3. Here x-coordinate is 6. So here x-coordinate is 2, and at this the second point of intersection the x-coordinate is 6. Okay, now we got the x-coordinates at the points of intersection of the two graphs. Okay, now let me go to the original question. As I said earlier, the x-coordinate at the point of intersection of the two graphs is the value of x for which f of x negative g of x equals to 0. Okay, here we got the x-coordinates at the 2 points of intersection, that is 2 and 6. For these two values of x, this f of x negative g of x is equal to 0. And in these two values, we find this 6 in answer choice C. The correct answer choice for this question is C.